In the realm of mineral extraction, underground mining emerges as a pivotal technique for accessing ores beyond the reach of surface mining. This ancient practice dates back over 40,000 years, with the world's oldest known mine located at Bomvu Ridge, Ngwenya Mountains, Swaziland. Here, early humans mined ochre for use in burials and body coloring. Intriguingly, historical eras have been classified based on the predominant mining materials, such as the Iron and Bronze Ages, marked by extensive use of iron and copper tin alloys, respectively, for tools, weapons, and artifacts. Over time, the process of underground mining also changed. These changes are brought about by numerous developments in terms of the technologies and machinery used. Experts have found more effective ways to dig through the surface of the earth. These days, underground mining is done quite differently from traditional methods. Now, techniques are being developed to deal with issues faced in this field, such as difficult geological conditions, high groundwater pressure, and layers of hard and soft material. One of the ways this manifests is through the appearance of shafts. In mining, a shaft is a vertical aperture that grants access to subterranean resources such as gold, silver, and coal. Depending on the type of mine, it provides a variety of services like transportation, ventilation, and access to different levels of the underground. Constructing shafts for mining operations is not easy. It requires precision and a lot of efficiency so that certain geological conditions do not get in the way. This is the goal of a shaft sinking machine. First, there will be a 1 to 2 meter deep excavation where the initial section of the shaft is. Then, a support concrete ring beam is installed. The purpose of this is to absorb forces from the shaft sinking process. The lower segment ring of the shaft, which has an integrated steel edge that functions as a cutting knife, is assembled and raised first. The number of strands that connect stranded jacks and strand wires to pockets in the cutting edge is equal to the entire weight of the shaft. Then, the machine installation starts with a dummy frame to position brackets for the machine arms. They will be welded into steel plates that are cast into concrete segments. Using a mobile crane, the VSM machine is built with the proper arm lengths and raised into the shaft. When the shaft is finished sinking, 3 winches are utilized to lift it out and perform routine maintenance. For cutting the predetermined profile in the necessary portion, the cutter boom can be manually operated or programmed to operate automatically. To maintain the equilibrium of the groundwater table in the surrounding geology, the shaft is kept full of water while it sinks. The optimal excavation rate can be attained by adjusting the cutting movement and speed. The material that has been excavated is transported from a shaft to a surface separation plant via a slurry circuit. When dealing with sticky ground, the integrated centrifugal pump can manage the granular size of the material that the cutter drum has crushed and sliced. As the shaft sinks, separation equipment is chosen to fit the specific soil characteristics of the area. Of course, that isn't the only way things work in underground mining. When it comes to drilling holes in the rock face at construction sites, a shaft jumbo is used. It functions by drilling holes and strategically filling them with explosives so the rock is prepared. This explosion will obviously produce debris, but the shaft mucker is there to deal with it. It scoops up the fragmented rocks and transports them to the surface or to designated removal areas. All of these technologies have helped in building the deepest shaft in the world in the Mammoth gold mine in South Africa, which extends over 4 kilometers below the surface. Each of the types of shaft sinking, as well as the different technologies that they use, serve different purposes as well. Most of the time, the type of shaft sinking is dependent on the type of underground mining that will happen. To have a better understanding of these purposes, you should also be well aware of the different types of mining. For instance, soft rock meaning refers to the extraction of coal, oil, shale, potash, and other minerals from sedimentary rocks. These rocks are considered to be soft because they are less denser and easier to excavate. Given those conditions, it also means that they require less heavy machinery and are considered to be safer and less expensive too. Naturally, soft rock mining will require fewer explosives in shaft sinking. The mining methods will be different as well. In fact, The common execution of this is through the use of dynamite to break up the coal seam. This type of mining is crucial for energy production and chemical industries. However, in handling relatively harder metals like gold, silver, iron, copper, zinc, and nickel, hard rock mining is used. This type of mining requires deep underground operations through robust equipment and techniques that are fit for removing harder rocks. In the hard rock mining process, the initial step is drilling. Usually, a robust machine equipped with diamond-edged drills is deployed to create deep holes in the rock. This process is technically challenging due to varying rock hardness and unpredictable underground conditions. Miners have to understand geology to anticipate these changes and adjust drilling techniques accordingly. The drilling process creates precise holes for controlled explosions to ensure optimal ore extraction and reduce the risk of structural damage to the mine. These holes are then filled with explosives, setting the stage for controlled blasting. This fragmentation technique breaks the rock, making the ore accessible. Over the years, industry experts have continuously innovated to improve underground mining techniques. The latest breakthrough in this endeavor is the Komatsu MC51, a cutting-edge solution for hard rock excavation. This machine represents a significant shift from traditional blasting methods, offering a more efficient, safer, and environmentally friendly approach to underground mining. Advanced technologies, including intelligent machine control, which makes use of sensors and GPS to optimize digging operations and improve precision, are built into the Komatsu MC51. The machine also has cutting-edge automated blade alignment technology that minimizes component wear and guarantees peak performance. A tunnel boring machine, TBM, is an engineering marvel that seamlessly integrates mechanical, electrical, and hydraulic systems for efficient tunneling. At its forefront, the rotating cutter head chips away at the earth, supported by disc cutters for various geological conditions. The debris is then transported via a screw conveyor to a belt system for removal. Simultaneously, the TBM installs precast concrete segments for tunnel support, using an erector arm to ensure structural integrity. The machine's advancement is facilitated by hydraulic jacks pressing against these segments. Inside the control room, operators meticulously guide the TBM, aided by sophisticated computer systems that provide real-time data on its positioning and the surrounding geology. This high-tech orchestration makes TBMs indispensable in modern tunnel construction. TBMs are expensive to construct and transport, but become less significant for longer tunnels. TBM tunnel cross-sections range from 1 meter to 17.6 meters. Tunneling speeds increase over time, with the first TBM peaking at 4 meters per week. The Tuen Munchek Lapcock tunnel boring machine is the biggest tunnel boring machine in the world, with a diameter of 17.6 meters. This massive slurry shield machine is marginally bigger than Bertha, the previous record holder for the largest tunnel boring machine. The Tuen Mun Chek Lapcock connection, a 5-kilometer tunnel in Hong Kong, is being drilled by a tunnel boring machine. TBMs have revolutionized underground construction with their swift and efficient excavation capabilities, yet they face limitations in mining due to specific constraints. Ideal in stable rock formations, TBMs falter in unpredictable terrains, increasing the risk of cave-ins in fragile areas. Their suitability is also limited in mines with varied ore compositions. The transportation and assembly of these colossal machines in remote locations pose significant logistical challenges, particularly for smaller operations. Furthermore, TBMs, being custom-built for particular projects, lack the adaptability to fluctuating mine conditions. Another way to do underground mining is through rectangular rock bores. This specific rectangular tunnel boring machine, also known as the MDM5000, has successfully bored a hard rock tunnel with a flat invert in Fresnillo, Mexico. Underground mining, inherently complex due to its reliance on explosives and subterranean operations, is fraught with difficulties. This challenging environment exposes miners to a multitude of problems and risks, some of which can be life-threatening. It's important to understand these issues to appreciate the intricacies of underground mining. In underground mining, ground control refers to managing risks associated with the stability of the rock and soil surrounding the mine tunnels. One major risk is rock bursts, which occur when rocks suddenly fracture and burst due to stress caused by intense pressure at deep levels. It is classified as an artificially induced disaster by mining excavations. This happens through the process of energy accumulation, where energy is evolving and an abrupt release is happening. To mitigate this risk, one solution is bolting, involving the insertion of metal rods into the tunnel walls and sealing to reinforce and hold the rock or soil in place. To do this, they insert a steel rod into a hole drilled into the roof or walls of a rock formation. This can be done in 3 ways: mechanical, grouted, and friction. The most common form is mechanically anchoring a rock bolt through an expansion shell. As the bolt rotates, a wedge fastened to the bolt shank is drawn into a conical expansion shell. As a result, the shell is forced to enlarge against the borehole wall. The purpose of this is to provide support for the roof or sides of the cavity. Another solution is concrete spraying, which involves applying a layer of concrete over the tunnel surfaces to stabilize them and prevent collapse or rock falls. It is known to be a time and cost-effective, mechanized technological solution for shaft lining and concrete construction. By implementing these solutions, mining operations can ensure the safety of their workers and equipment, while also maximizing the potential for successful mineral extraction. Ventilation is a critical aspect of mine safety, particularly in deep underground mines, where the risk of air pollutants and extreme temperatures is high. Proper ventilation ensures that fresh air is circulated throughout the mine, reducing the risk of health problems for miners and improving overall working conditions. Since mining works on the surface of the earth, it is quite difficult to get enough ventilation. There are several solutions available for ensuring effective ventilation in hard rock mines. One option is to use ventilation fans, such as those provided by Howden Mine Ventilation Solutions. In underground mining, ventilation fans are used to supply a steady stream of air to remove heat, moisture, and hazardous gases produced by mining operations. The fans are arranged thoughtfully throughout the mine to provide efficient air circulation, and they are usually powered by electricity. These fans are designed specifically for use in harsh underground environments and can provide powerful, reliable airflow to keep the mine well ventilated. Another solution is to implement an ABB Ability Ventilation Optimizer tracking and tagging system. This system uses sensors and software to monitor and optimize airflow in the mine, providing real-time data on ventilation performance and helping to identify areas for improvement. These sensors will be placed strategically inside mining sites, along with tags or transmitters attached to mining vehicles. Once a tag goes off or gets detected, the tracking and tagging system will locate that tag and increase the ventilation in that area. In addition to these technical solutions, it's important to ensure that all mining operations follow strict safety protocols when it comes to ventilation. This includes regular monitoring of air quality, proper maintenance of ventilation equipment, and training for all personnel involved in mine operations. Underground mining is composed of a variety of systems and techniques, one of which is the room and pillar mining method. This refers to a system where the mined material is extracted across a horizontal plane and results in a horizontal array of rooms and pillars. This is commonly used to extract ore deposits with a dip of less than 50 degrees, while leaving supporting pillars to maintain the integrity of the mine. There are a number of methods that can be used to guarantee the stability of these pillars, including the use of steel sets, reinforced concrete, or other support materials. Moreover, during the mine's life cycle, routine maintenance inspections and monitoring are required to avert any possible weakening or failure spots. When it comes to machine operations in this context, big equipment like loaders and haul trucks are frequently used between pillars to move extracted material swiftly and effectively out of working areas, which streamlines production processes and always raises safety standards. The room and pillar mining method requires extreme efficiency and high precision. This is why miners plan before starting it. It needs to have efficient mucking and loading to optimize resource allocation for maximum productivity gains. Now that we have mentioned mucking and loading, let us get to know them through the machines used in these processes. The Komatsu LHD series are loaders that have been engineered from the ground up to revolutionize small and narrow vein mining operations. They are built with a sturdy chassis that provides stability and maneuverability in challenging underground environments, as well as a powerful powertrain that ensures maximum power output without compromising fuel economy. The Komatsu WX07 LHD is even known to have up to 10% more breakout force than any other machine in its class. The energy needed to move an object from its current location with a robotic arm or other mechanical methods is referred to as the breakout force, BOF. This may involve, among other things, piercing through materials like steel or concrete. On the other hand, tramming speed, TS, can be simply defined as the speed at which a payload moves once the system starts moving it. TS is defined as the rate at which the load moves along the rail when it is being accelerated. For short distances within the mine, these loaders can transport the material directly to a designated dump site. However, for bulk transportation, especially over longer distances or to the surface, the material is typically transferred from these loaders to conveyor systems, miner trucks, or rail cars. Now let us move on to hauling. This process is also assisted by machines, and one of the examples is the Sandvik TH540. It is a high-performance 40-ton articulated underground dump truck that can be used in 5 by 5 meter tunnels. This truck is designed with operator safety in mind. This is ideal for level or steep ramp production haulage in medium to large mines, and even tunneling projects with restricted height. It uses a combination of diesel power and electric propulsion to move materials efficiently and safely. The TH540 employs an electric drive system consisting of 4 independent motors, one for each wheel, and a controller that manages the speed and torque of each motor. This system provides precise control over the truck's movement, improving efficiency and reducing wear and tear on the engine. A manual or automatic transmission is available for the TH540, depending on customer preferences. Both options provide smooth gear shifting and efficient power delivery to the wheels. Longwall mining involves a highly mechanized process of removing a large panel or block of coal in a single slice. The main feature of longwall mining is the longwall shearer, a large machine with a rotating drum that moves back and forth across the face of the coal seam, cutting the coal, which then falls onto a conveyor for removal. The entire operation is automated and includes advanced roof supports to protect the miners. This method is highly efficient for extracting coal from thick seams, but requires a significant initial investment. The process of building tunnels, or entries, that grant access to the mining region is referred to as entry development in the mining industry. This critical stage entails cutting into the coal seam and extracting the needed minerals using specialized equipment and methods. The various entry development techniques and their uses in the mining sector will be discussed in this video. Retractable cutting drums are machinery used in underground mining for entry development, minimizing damage to surrounding structures. Equipped with carbide-tipped teeth, they maintain consistent cutting depth without manual adjustments, increasing efficiency and reducing wear. They can be easily removed and replaced, extending their lifespan. Modular design, involving interchangeable components in machinery and equipment, is increasingly popular in mining due to its flexibility, reduced maintenance costs, improved efficiency, scalability, and standardization. It allows for easy customization, reduced downtime, and increased productivity. Modular systems can be scaled up or down to suit different mining operations, making them cost-effective and practical. In soft rock mining, pitch steering is the technique used to regulate the drill hole's orientation during blast hole drilling. Drilling into relatively easily broken rocks, like sandstone or limestone, is known as soft rock mining. In order to increase drilling accuracy and efficiency, pitch steering is used to make sure the drill hole stays perpendicular to the rock face. Technology like armored face conveyors is essential to longwall mining process optimization. AFCs are intended to safeguard the conveyor system and protect machines from possible dangers, such as falls and bursts of rock, guaranteeing improved safety precautions and ongoing operation. These conveyors have impact-absorbing armored plates that minimize damage to the machinery and repair downtime. As a result, maintenance expenses decrease while the overall output rate rises. Specifically built for great productivity and efficiency in underground coal mines, the Joy shuttle car is a unique piece of mining equipment. This car is especially notable for its adjustable driver's seat with armrests and joystick control system, which make it easy and comfortable for the user to maneuver the vehicle. With a variety of features like flexible conveyor trains, FCT, autonomous load haul dump, LHD capability, and sophisticated automation systems, the Joy shuttle car is made to be extremely versatile and adaptive to multiple mining circumstances. These features save downtime and boost overall productivity by enabling the car to deliver huge amounts of stuff securely and efficiently. Mining sites also have feeder breakers. These are designed to consistently crush and break down materials to prepare them for processing. The machine is programmed to break the material down into specific measurements. Most feeder breakers can handle coal, potash, gypsum, graphite, and limestone. To ensure the safety of the miners and the machinery involved, several safety systems have been developed and implemented. For instance, Komatsu has developed the roof support solution, which includes a custom-engineered and remotely managed longwall system. This not only improves safety but also increases productivity without harming miners. Komatsu also has its own way of testing things, so quality and safety are ensured. This is along with their roof support PRS solution, which has a support rate of up to 1,129 short tons. Mining sites also have the Smart Zone proximity system. This uses personal proximity detection systems, which are designed to alert operators to hazards in low visibility and obscured locations. They use low-power wireless transceivers in RS-20's FaceBoss mimics to determine the location of individuals wearing a battery-powered tag or personal wearable device, PWD. Data is collected in underground mining not only for record-keeping but also for other important reasons. First, collecting real-time data from sensors and machines allows mine operators to monitor hazardous conditions and potential risks to workers' health and well-being. Second, it helps them keep track of their productivity levels. Third, automated data reduces manual labor demands and unnecessary movements from machines. This helps make the site significantly greener since less energy gets consumed when machines do tasks. Fourth, it helps with increased precision. Thanks to the use of sensors directly linked to the machinery, mining equipment operators may now access real-time measurements based on the performance of various components individually or collectively across numerous pieces of machinery, offering granular insight into machine functionality. Finally, through process standardization and the elimination of variability brought on by human mistakes or disparities in interpretation, automated data collection improves repeatability. Working inside mining sites truly poses great safety concerns. As long as there is manual labor needed inside those sites, this cannot be avoided. This is why many experts have been looking at autonomous machines as a possible solution to these issues. For example, mining sites could benefit more from remote control machines because they allow miners to work remotely. They work within a safe distance, so safety is ensured and evacuation is easier if it is needed. It can still function like normal mining, but with fewer human interactions. The AutoMine mapping system is a cutting-edge tool made to optimize user safety and productivity. To avoid interacting with big trucks, it scans mines using a 3D scanner installed on a light vehicle. High primary asset utilization and enhanced safety are made possible by the solution. It is deployable for any underground AutoMine equipment and is quick and simple to operate. Technology has truly brought us so far. Today, we can already see autonomous loaders as well, just like the AutoMine. This is a concept underground drill, designed with a twin-boom development drill rig. that operates entirely on its own without the need for human intervention. The complete drilling cycle, including tramming to the face, setting up for drilling, drilling the pattern, and returning home to recharge for the next cycle, may be planned and carried out by the cabinless battery electric drill. Remember, every piece of ore extracted tells a story of human determination and technological advancement. If you found this exploration as fascinating as we did, don't forget to like, share, and subscribe for more content. Thanks for watching, and stay curious.